Hi all, hi student. This is Professor Zhang of Bugyeong National University. Today I will talk about electromyogram, EMG. Basically this lecture is for AI students. So many AI students and AI graduate students handle with the bioelectric signals like EMG, but many students do not understand the inside of EMG, how it is generated. So today I will talk about the detail about electromyogram. Okay, I will explain what is EMG and how it is generated and how we can measure EMG and how can computer understand EMG. So, okay, let's start from our muscles. Okay, so we have lots of muscles. Not like this big, but we have some. The muscle is soft tissue, which is responsible for producing movement by contracting or relaxing. Okay. And if we magnify our muscles, it looks like this. Okay, muscle is composed of multiple fibers inside of a epimysium. Okay, and this is you see this is one muscle, and there inside there are many fibers of muscles. Okay, so this is a muscle have a hierarchical structure inside. Okay, we can move our muscles, right? Because I can move my muscles like this, and when I try to move my muscles and my arms, for example, and my brain gives some signals, of course, isn't it? So my brain gives signal to my arm, and when the signal touches my muscle on my arm, then it trying to contract, and yes, our bones are moving according to our muscles. Then we can see more details. So at first, our brain trying to send some signals, and then it's a electric signal, an electric chemical signal, and it comes from our brain and it touches to our muscle. And you can see here, sorry that there are many Koreans here, but it's not important. You can see some English terms here, and the signal comes to the touch. The signal touch the muscle, and then I can't sure about the English pronunciation here. Acetylcholine. Yeah, the nerve releases a chemical called acetylcholine, and this acetylcholine attaches to receptors on the muscle cells outside the surface. Okay, so these chemicals come from here to inside, and then this causes changes in the muscle cells membrane. So membrane is a kind of a wall of our cells. So there is a muscle inside, and then there are outside of muscle, right? And then the very wall is between the two separating two regions to rain, we call that membrane. Okay, anyway, and then sodium ions, natrium in Korean or in Latin, the sodium ions enter the muscle cells. And when the sodium ions enter the muscle cells, and then before talking about that, I told you about the membrane, and this membrane separates the inside of muscle and the outside of muscle cells, and then the nerve touches here, and when nerve gave some signals, before giving the signals to the membrane, and there are some electric potential differences between inside and outside of the muscle, outside of the membrane. And this is caused with many reasons, but I do not want to talk about those reasons. And this potential is around minus 70 millivolts. So inside is minus and the outside is plus. This is a relative potential. So comparing to the outside, so inside potential, electric potential is lower. So this is minus. Inside is minus and the outside is plus. And this is pretty stable if we do nothing. If we don't move, and if our cells do not give any signal to the other, then let's say it is very stable. But when our nerve system gives some signal to our muscle, then this membrane, this state, is changed. And then the sodium ions starting to enter the muscle cells. So sodium ions are plus ions. So if plus ions go into the muscle inside the membrane, then what happens? Yes, electric potential increases. So at first, the electric potential here is minus 70 millivolts at first, and then it starts to increase, and then until it reaches to plus 35 millivolts around. And then we call these changes as the action potential. Okay, and after that it will decrease again. I will explain about this later. And at this stage, when the action potential occurs, then this action potential releases calcium, which is saved inside of our muscle, and then this causes muscles contraction. So it's starting to contract. So muscle is like works in this way. Okay, works. The structure of muscle is just like this, and then it is contract and release, contract, release, and then yes. So until now, you have I have explained the polarization, and depolarization. The polarization is means that the potential polarization is the potential difference between the inside and outside of the membrane, and this difference is going to be changed when the signal comes from our brain to the membrane, to our muscles, and then this potential suddenly increases. We call this phenomenon as the action potential. And when this action potential occurs, then our muscles starting to contract. Okay, and then without the signal from our nerves, this electric potential is starting to decrease and come back to the previous states of polarization, and the potential is electric potential becomes stable once again. So this is we call this as the repolarization. So there are states of polarization, plus and minus, and depolarization, go up, and repolarization. okay, come back and stable again. And this process is repeated continuously. Especially, I mean, here when the nerve signal comes to here, the action potential is starting to at this point, and this action potential is starting to spread along to the muscles. Okay, and when we are trying to think, when we're trying to move our muscles, then we do not just think, okay, in 1 millisecond or 0.1 millisecond or something. We continuously think, okay, I try to move our muscles. Okay, we try to, in our brain continuously sending signals to our muscles. So in time series, our brain continuously sending the signals, and this action potential occurs continuously even at this spot. And action potential continuously occurs at this spot, and then is continuously spreading along to the membrane, along to our muscles. Okay. Then this signal, we want to measure this signal. So this is the muscle signal, right? So we want to record this muscle signal. This might be the EMG, electromyogram. So best way, maybe we may measure the signal of EMG, putting the electrodes one inside of the muscles and one the outside of the muscle. Then we can measure the action potential continuously. But this is very difficult because yes, we need to put inside our muscles. So this is painful for the patient or for the people. So I never tried it before, but one of my colleagues is a doctor, MD, medical doctor, and he said that this is really painful, and many of his patients do not like it. Okay, so usually we measure EMG on our skin. You can see this arm, and we can put the 3 electrodes just like this, and then we may measure the EMG. So this is not very accurate, maybe not as accurate as we put the signal, the measurement of putting the electrode inside of our muscles, but this is much used, pretty much popular and more used in public because this is a lot easier. So when we are measuring the EMG on our skin, this is a little bit different to what I explained before, because we cannot measure the electric potential of inside of a membrane and outside of membrane if we put 2 electrodes outside of the skin, because the 2 electrodes are outside of the membrane anyway. So, but instead, when muscles generates electric potentials continuously, then it comes to each electrode. So, and the time and distance from each action potential is going to be different. Okay. Then, if we measure the signal by subtracting one from the other, like A minus B, then we can get a kind of signal reflecting our muscle activities. So this is one example of electromyogram, and this is there is number 1 upper signal is the low signal. So when you measure EMG, it's just like this. Okay, so it's difficult to understand and recognize it. But if we try to use deep learning, yes, it is possible. Maybe it's possible. And if you are trying to deep learning, it is possible. But you need lots of data. Yes, if you have lots of data and you just put your deep learning models and develop your deep learning models well, and then maybe it works. But traditional approach is doing some kinds of pre-processing, doing some pre-processing. And the first one is frequency band pass filter. We put some band pass, like it differs to the researchers. Some researcher put 8 to 200 or 10 to 500 or even 0.1 to 200 or 100 hertz. So yeah, so there are no such answer or correct answer for this pre-processing, but in general, yes, it's not that important. It's just you can choose it. You can try. You can see your signal first, and then try to apply some different bandpass filters, and then check your signals. Then you can see that if I use this kind of bandpass filter, then my signal is going to be distorted. But this is okay, and you can try this and that, and you may choose one. And notch filter for 50 Hz or 60 Hz is going to be necessary if your device is using with other electric devices, and then other electric devices near to your measurement tool, then this kind of noise, 60 Hz or 50 Hz noise could be attached to your signal. And another thing you can do is smoothing. So using a sliding window, you can get the moving average or moving median filter. And most common thing you can do is RMS, root mean square. This is also using the sliding window. Just, you can see there is a blue box here, and in this blue box we can measure, we can calculate the mean square. So square and calculate average and apply root. Then it's going to be the amount of the power you can get it with this simple equation. Then move this sliding window slightly, and then calculate this RMS once again. Then you can get the signal. And you do continuously. And then you can get the signal like number 2 up below. Okay. Then usually you can use this RMS signal for your deep learning models, or you can use this RMS signal to calculate another feature. So this is a kind of general approach to recognize EMG signal. So using the EMG signal, you can try to recognize hand gestures. Yes, like hand gestures, and also arm gestures. And also, if you put the electrodes on your faces, and you can also get the signal from your facial muscles, so you can measure your face, you can recognize your faces without camera. So this is going to also pretty interesting research. Okay, and this was my lecture, and today I explained what is EMG and how it is generated, and how we can measure EMG, and and how and can computer understand this EMG, okay, shortly. Okay. Thank you for your listening and your attention, and then I will see you in the next lecture video. Thank you.